Yeah.
Teleport over there. Bit higher, bit higher.
Oh, Windows.
Bit higher.
Check the monitor.
That's it, just because we plugged you into the big telly.
Yeah.
So now, teleport to that edge way.
Oh.
And do one step backwards in the real world. One step back.
Oh,
Bit more, bit more, bit more. Now teleport to the edge again.
Okay.
That's it. And now, with your feet, move your feet forward and look out. A little bit further and look left and right. You see a fire engine.
Okay.
That feeling you got now is the impressive feeling of VR. Like photogrammetry VR.
I don't want to fall.
I know.
off the thing, even though I know it's not real.
I know.
But it's pretty convincing that it's...
It's because it's photogrammetry, it feels better than a synthetic cartoon world.
Oh, that's frightening, isn't it?
Yeah, so teleport down into the alleyway now.
Can I do that?
No, yeah, see this blue circle? There you go. Now look.
5. Where is this filmed?
Mexico.
No, this is Compton Vernage, down the road from me.
Does it...
Shit.
Oh, we have the pants.
We call it cock and snoofle.
Oh, man. I didn't know where
Where's
the
Dima?
pants.
So, welcome to the world of haptics.
All right.
I've got nothing. I can't see anything with the controller. Yeah.
Were you in the circle? Did
bullshit. It's got physics to it.
Are you...
the suit, you get full kinematic and skeletal.
Okay.
And feet and hand.
Oh, yeah. You know where to measure this.
And rotate. Well, we can.
Does this have a
Rotates.
accelerometer in it?
Yeah. And you can
Right,
also,
there you go.
yeah, but you can also put a 5-tracker here. That's what that
Oh,
port's
it's for
for.
a tracker. I think as long as there's an accelerometer, we'll know the orientation of the wrist.
Mm-hmm. Is it full IMU like gyro
Yeah.
and accelerometer?
Yeah.
Okay.
I want to hook it up to the. One of them was
Which was this?
dying the battery because I was playing with it for so much, so I'd use the opposite hand.
What is it?
No, keep a minute.
Oh, is it just compressing your chest right now?
This bit will.
It's everything, yeah.
Are you feeling the inertia? Are you feeling that?
You want us to pull you out? How do we stop it?
Oh man.
How do we stop it?
Is that stop?
Oh, we.
Yeah. Control Alt Delete. You've been busy.
this is the new Thrustmaster.
You gotta do it with the right robot. You're gonna use our product ones, right? Our product is warm. I'm gonna get this one out of the.
They have to read.
There's so many degrees of freedom that, like,
Hmm.
Okay, close.
Close.
You're trying to be fast as well. Yeah, but you know, we're not running the. So we have a separate AI software that specifically runs to grab items like this, and we're not running that right now on this robot. So you know, for now. Low latency.
Say again, Alex. Sorry.
This is the video feed out of our UltraView product. So it's 4K, 120 frames per second, super low latency. So it's basically instantaneous.
Seeing exactly what the robot's seeing.
Yep. And it's 360, so you can see all around it.
Mm-hmm. That does. The latency looks wicked.
It's instantaneous.
Hello. Oh, yeah.
That's cool when it does that little, like a gimbal head.
So where is it?
We're ready.
Oh no, it's just, yeah, it's not filming at the moment.
Isn't it?
You can try it. 3, 2, 1. Yeah, filming. And then slowly go back at it. Yeah.
Here, let's do a VR with this, and then you know.
Whoa!
Grab your nose and run off.
Yeah.
And then you could do even like,
So that's like, so you can go here and then
like, yeah, you can, you know,
you can do this.
you can really just go ham sandwich with this. All right, Spot. I'm sorry. And its actual normal up orientation is here. Right? Yeah. 'Cause that's the normal use, but then you know the wrist, like, that's a lot of degrees to deal with. There's a reason why I want to use the glove and suit to do it. Okay. Just for less intensive. So let's say we're not crunching thousands of FPS. We're doing like 60 FPS on each or 120 FPS on each. We just crunch it in the GPU at that point.
Right.
So we plug in the cameras and then a GPU right here, and then this into the computer.
Yep.
And we just bifurcate the signal, right? So that's the motherboard's problem. But we still keep the FPGAs on the sensors, and we DMA transfer that data over the PCIe to the GPU memory and just crunch it with this. So this is cheap, because this costs like almost nothing to make, right?
Almost nothing, meaning $100.
Yeah, like these connectors are like really expensive because they're shock and vibrated, so it
Right.
actually costs like multiple hundreds
Yeah.
to do a simple PCB. But this one is $4,000 to produce.
Wow, that's a lot.
It seems to be the more expensive things are, the harder you drop them on the table.
I mean, you know that
It's designed for that.
that's old. That's old now. So that was an engineering sample.
He doesn't care about it.
It continuously, so we need to trigger it, right? So we use GPIO to like say, okay, you know, actually run the radiation. So So there's points to having the GPIO in addition to just the communications. So we can have analog triggering of different sensors. Like if we have let's say like a spectrometer, laser spectrometer, right? 465 nanometer laser spectrometer, Raman spectrometer. That also we trigger, right? You don't want just, it'll blind you. So we trigger that. And then this power aux is for the camera output too. So normally our cameras will take, those little cubes will take like 5 to 96 volts DC, anywhere in that range. And it'll buck them down to the right voltage at the termination.
Right, yeah.
But X-ray needs higher voltage. So we can still keep a 12 volt system, but add the high voltage out. And it will go through that little ribbon cable that we have.
Super.